This is just kind of a mini review and update on, basically the power meter project I mentioned a while ago. Also, it's going to be a minor review of one of the interesting board houses, the Osh Park PCB thing, which is where these boards came from. So it's basically just like a couple bucks a square inch or something along those lines. I think this was it was 32 bucks for 3 boards. One thing I'm not too thrilled about is the shipping. I mean, they just literally, you get boards in a baggie. I mean, I guess there's not much you can do to them, but I don't know, maybe some, like, all the other board houses I've dealt with generally shrink wrap the boards so that they can't kind of rub against each other and be abused. But they seem to have come out they seem to be in fine shape. So let's just take a closer look. So here are those 3 boards you can see. One of the things you'll notice is that the depanelization is literally the absolute minimum effort they can put into it possible. They break them into separate sections and then stuff them in the envelope. So you can see actually it looks like on all of these I got most of the basically the depanelization tabs. And then there's also this, which is, I guess there was a space fill, however they panelize stuff. Fortunately, this stuff does break off pretty easily, but then you have to sand this, so it's not quite as nice as completely individually routed boards, but I can live with it. So one of the things you notice is purple silk screen, or excuse me, purple solder mask, and it's ENIG plate. It's an ENIG finish, so that's electroless nickel immersion gold. So you can see that all of the pads and everything on the board are gold plated. This is the board for the power meter. I did a video on this power meter thing a while back. This is the first board, kind of the first messy but thrown together board rev. I'm actually going to go stuff this later this afternoon. It is going to be open source once I kind of put everything together, so that should be visible at some point. It's just ATX Mega, some isolation. This is a little cheapy offline power supply, and I cheated and used a module because I didn't want to have to deal with laying all that out at the moment. It'll, going further, moving forward, it's going to be non-isolated, and we're going to have a discrete power supply so that we can drive the costs down. This is probably, I'm working on this with a couple other people, kind of a collaborative effort, and we're basically the target goal is to drive the cost for like a smart energy metering system where you have a whole number of these, and then probably in the center like one Raspberry Pi with an NRF on it. So it uses these very kind of ridiculously inexpensive NRF24 LO1 Plus modules that you can buy on eBay or wherever. They just look like this, and they're like $1 or $2 a piece. And the pricing on that is just so ridiculously low that there's really no other wireless option that can beat that. So, basically that you use one of these, which actually in this situation just we'll just go right here. And again, this is not a final board layout, this is the test where you can see you have lots of test points and crap like that. And then there's a central hub location somewhere. This is another board I had done recently, which is just a convenience thing so that you can hook up, an NRF more easily. And then I've written some Linux software to, poke this. But basically the idea is you have like a dense energy metering where you can have, kind of like a kilowatt hour, a kilowatt, wall appliance or wall thing, but rather than having an LCD, you have a wireless link, and then it's mesh networked back to, the central station, and then you can get, statistics on power consumption for all sorts of things around the house. And the target is to be like $20 to $30 per outlet. Some of the stuff has to be worked out. We haven't, totally done everything, but, just working up some, doing some quick, bomb counting and stuff like that. It should be definitely viable, and the idea is if you can drive those costs down far enough, it becomes economically viable to basically put them everywhere. So, this is the first prototype. Actually, you can kind of see that it looks like the solder mask has been a little abused on those traces there. Yeah, there's actually copper visible there. So I wish they'd package their stuff a little more carefully, but, it was $30 for these, so I'm not complaining that much. As you can see, there's still some the breakaway tabs go with one of the boards. Actually, for the Raspberry Pi boards, I had more made because I was pretty confident these would work, and you can see they actually... Obviously the way he does it is he does, you know, basically they order it in runs of 3 panels, and then they break them apart, so because I ordered 6 of these, they, you know, it was doubled up on each panel. So I get the little breakaway tab as a bonus. And they come as a unit. But, yeah, so I'm going to stuff these, and then we'll have some more information in this, you know, in the near future. So, one afternoon of stuffing parts later, we now have boards. So either the parts have found, the boards have found parts, or the parts have found their rightful place on the boards. As you can see, I stuffed 3 of them. So, went together pretty nicely. A couple just kind of herpaderps. Fun stuff. So these 4 resistors, 1, 2, 3, 4, form basically a voltage divider. So it's these 4 resistors in series into 1K to ground. And that's the potential divider for the 120 volts. And they're supposed to be 422K each. So 4 times 422K. And of course, I kind of derped and forgot to order the 422K resistors. So I wound up using 3 500K resistors and 150K resistor. And I did the math, and I think it's around 3 or 4% error. But there's calibration constants that you set in here anyway, so I'll just have to, I can cal it out without any trouble. Other fun stuff, I don't know why I made these 6 capacitors here of 603 when everything else on the board is 1206, but I managed to order the capacitors that fit on these footprints in 1206 as well. So that wouldn't work. Fortunately, I had 0805 parts on hand at work that I could just were close enough that I could kind of fudge them in. And you can, if you're not very tightly packed, you can populate 0805 parts on a 603 footprints without any real issues. Other than that, just silly stuff kind of bothers me. I bought these caps, and I checked the footprint against the capacitors when I was doing all my ordering and everything checked out, but I didn't realize that they were lead formed parts. So you can see that they've got, they come pre-lead formed to fit in the holes properly, but then they have this big set off distance. And I don't like that. So what I do in the future, again, this is a prototype, I don't really care. But, if I was doing this again, I would find the part number for these capacitors without the lead forming, and then I could have them sit right against the board. Not a big deal, it just kind of bothers me. Other than that, they went together nicely. You can see there's a little bit of flux goo on the back, but only around these few places. I scrubbed the board, but I did that before I put in the little DC to DC module that goes from 170 volts DC to 5 or 12 volts. Because I'm not too sure. Basically, the desoldering, I make my own deflux or flux cleaner. It's just 50% methanol, 50% acetone. And I wasn't sure if I could wash this with that, so I soldered this afterwards. I also soldered this connector, the socketed connector afterwards, because these are a bear to get liquid out of. They're just hard to totally clean out. So you can see that the flux is kind of a little bit of flux left around there. This doesn't really matter, it's 3.3 volts, and here I went at it with Q-tips to make sure that, this area is clear, and, this area, all the stuff around here where you have large voltages. There's 160, 170 volts between these 2 pins, 170 volts between those 2 pins, but, over here we only have 12 volts, so there, being a little bit of flux pollution on the board isn't a big deal. Some other stuff. This was it was like a one-sitting board. Really, it was a couple, a few hours, couple hours to do the schematic, and then a few hours to do the board layout, and then I just ordered it without really spending much time, kind of sitting on it and making sure that I had everything nicely done. So there's a few little minor herpaderps. You can see that there's some designators kind of messy here. It was kind of nice to not really spend a lot of time worrying about shit like that. Normally I take 2 or 3 days of just kind of going over things and cleaning it up. Not really working on it full tilt, but just looking at it, trying to get distance from it so you can kind of come back and look at it with a fresh perspective, in which case you generally see all of the stupid stuff you didn't notice the first time. Some other stuff, like normally I try to tent vias, and apparently I had that setting turned off and I didn't catch it because I wasn't really looking very closely. But everything, electrically it should be good. It's just, some minor layout herpaderps. Like other things I wish I had done. I wish I had put at least a power LED on here, but nah. Whoops. So you can see that there's a... If you look on the bottom here, you can see that there's basically 2 completely isolated sections. So, again, I think I said this earlier, I don't know, but the plan is eventually this is going to be, we can ditch the optos and a lot of this additional complexity and just have the microprocessor, power management IC, Probably our own discrete offline switch power supply, you know, kind of basically this, only done with discretes, which gets us from like $6 to $1, $1.50. You know, and the whole, I think the whole BOM is like $12. And, you know, that includes, you know, these things, it's just ridiculous. I was looking at these, I just had a burrito. And I was looking at these on eBay, and you can buy 10 of these for, you know, 10 of the entire module with the crystal and the device and all of the passives. You can buy 10 of them for $12 plus $1 shipping. I don't know how they do that. It's kind of insane. But, you know, what can I say? So, you know, the USB interface at this point is just basically for powering this. It's wired up. I haven't actually worked with the USB interfaces on these chips before. I may play with it, try to use it as simple serial, but, you know, I think these are mostly going to be used for, you know, basically I'm mostly just going to use the NRF for communication once I get that working. And the, you know, again, I have the full-blown, you know, hardcore, you know, in-circuit debugger, you know, an Atmel1. So, you know, I don't really need the serial port. You know, some other stuff like, you know, this is a slightly more expensive voltage regulator than we really need. The whole circuit, I think it's, you know, 10 milliamps, or no, 5 or 6 milliamps. This thing draws 12 or 13 milliamps, and then you need 3.6 milliamps for this. So the whole power budget is about, I think, it's about 18 to 19 milliamps. I'm forgetting something because it was, I worked it up the other day and it was 25. I don't remember. But, you know, basically, we're going to have one of the things we looked at is just using like a capacitive dropper, which we just can't quite squeeze enough power out of it. So we have to use like an active switcher with an inductor, which is basically what this is. This is just a potted module that I bought because it takes less effort. But yeah, I mean, you know, the idea is to get the BOM cost as low as possible, then possibly put together like a Kickstarter or some sort of mechanism, you know, some sort of thing like that, where you buy one and you get like a Raspberry Pi with the software on it, and, you know, a couple of them, maybe 3 or 4 or something, I don't know. And basically the idea is to try and push the costs for, you know, basically doing, you know, high density energy monitoring, ergo monitoring, you know, most of your appliances down to the point where it's really approachable, like on the same scale as a kilowatt hour. Excuse me, as a kilowatt. I always want to say kilowatt hour, you know, per outlet. And, you know, here's the first prototype.